Okay. I just totally forgot I couldn't plug it in my calculator. Yeah, that makes a lot of sense.
All right, so the next one I think is pretty similar.
Mm-hmm.
And we'll let's take a look here. All right, so Jessica has been tracking the population of a town. The population was 8,230 last year and has been increasing by 1.25 times each year. What function can Jessica develop to model this? So this is a growth model.
Okay.
Okay. And the growth model indicates that there's always a starting point. Okay, so it's like P A to the T, A equals P A to the T.
Mm-hmm.
So the population is 8,230. When it's increasing 1.5 times, that's A, all to the power of T. Okay, so this is the function. This is what you will. We just need to turn a moment here.
Mm-hmm.
Okay. All right. So that's it. I mean, that's the answer. That is the answer here.
So you just plug it into the function and then that just be the answer? You wouldn't have
Yeah.
to like solve it or anything?
That's it. They just want you to write the equation.
Oh, okay. I usually maybe I solve it sometimes, so maybe that's why I keep getting it wrong.
Well, usually you're putting a number in, like you're given a
Yeah.
value for T, like it'll say, what's the population in 10 years, in 5 years, and 2
Yeah.
years, things
But
like
it
that.
doesn't
But we
really
don't,
give that, so
doesn't give anything like that. So you don't have any of that information.
I don't
So
know. Sometimes I like to make my life a little harder.
give me just a moment here. I'm gonna grab some water, but we'll
Okay.
keep going here in a minute.
Okay.
All right, let's take a look at the next one here.
Okay.
Number
B
3, yeah.
point
All right.
2.
All right, so express 3 to the 4 as a logarithmic function. All Right, so what that means is that you have to change this, and I basically have to give you the answer so you can see it. It becomes log base 3 of x equals 4. So let me just rewrite what's there. And you can see where everything is mapped.
Okay. So it's kind of like you putting the log there and switching the 4 and the x.
Yeah, some people call it like the candy cane. You have to know how to go back and forth. Like there are two types of questions they give you. It's rewrite the exponential as a log, rewrite the log as an exponential,
Mhm.
and that is it. So
I do remember that part of
okay, good,
that.
good. All right. Okay, number 4. Like this. All right, so evaluate log 8/16, base 8 of 16 using the change of base formula. So it's log base 8 of 16 equals. So all you have to do here is map like where does the b go? Where does the y go?
Mhm.
Well, the y goes up top, so 16 goes up top. The
And
8 goes on the bottom.
Mhm. Would you have to solve it after that, or would you just?
It does not require you to do that. Now, you can, but it doesn't say to. Well, actually, I guess it is implied. I'm trying to think about this. So the way this works is 16 can be written as 2 to some power, and 8 can be written as 2 to some power.
Mhm.
So what is that? What is 2 to what power is 16?
Um, 2 to the power of 2 to the power of 4 is 16, and then 2 to the power of 3 is 8.
Okay. So it's log 2 to the 4 over log 2 to the third. And there's your answer, 4 log 2. So you can actually bring this exponent out in front. That's another property of logarithms.
Oh, okay.
And then this becomes 3 log 2, like that. And then because the logs are the same top and bottom, you can cancel. And that becomes
It's 4
4.
over 3.
Yeah.
Oh, okay.
Right. So the answer is 4/3. That would be on your thing there.
Mhm.
So go ahead and
Hmm?
all right. Very good. Okay, so let's take a look at the next one here. Hmm, all right. So next thing here is to look at sorry, it accidentally closed it.
No, it's okay.
Is this helping today, or does it feel like it's
Yeah, yeah, it is.
okay?
Because like some parts
Give
of
me
it
give
are
me
good,
just a
and then
moment. I'll
other.
be right back.
Oh, okay.
All right, I'm back here. We're doing number 5. Let's see if here we go.
Okay. Function. Function.
Okay, so function represents the growth function every year. Dr. Krista wants to manipulate the formula to an equivalent form that calculates every half year, not every year. What function works for Krista's purpose? Okay, this is a pretty complicated question. Do you actually think you're gonna get something like this on your exam?
Well, the math teacher I have was my old math teacher, and she kind of did stuff like this where she put questions kind of similar to it.
Okay, so what we're gonna do here is we're gonna go to the other screen here because it's easier to do this graphically.
Okay.
So if you're seeing my screen, y equals 10 to the 10 times 5 x. And then what we're looking for is something similar. So it's like, well, what do we do? So if we like uh every half year, that's usually divided by 2. But see how those aren't the same?
Mm-hmm.
And the question is, well, what if we change that? Like, how do we make everything kind of line up so the graphs are the same? So you get into this like, well, what should we even manipulate to make it the same?
Mm-hmm.
And so right now it's if we go 2x, that's another way to look at this. Okay, it's 2x, and we put a 5 there. Sorry, a 2.5 there. Will that work? No. But if we take the square root of 5, because we're squaring it, magically we get the right answer. And I just don't know how much of this truly like you would understand or know to do. The best way to do it would be to actually just graph a bunch of the answers on the test to figure out which one is right, which one gives you the exact same graph.
So it's all just about like plugging it in and seeing what is what.
Exactly.
Okay.
So, um,
Interesting.
yeah. All right. So we'll go back to the other screen here. I'm going to take a look. There's a bunch of ways to manipulate this, so just keep that in mind. But yeah,
Okay.
let's take a look here at the next one that you sent over. All right, so it's transformations.
Mm.
And there's kind of a lot that goes into this. It's like, there it is. It's like, well, what is the transformation? So this 1/4 is the transformation.
Mm-hmm.
And it's like, well, you don't even know what the parent function is because it's kind of unclear, but I believe it's 4 to the x is the parent function. The way they're kind of writing this. So 4 to the x is this, okay? And then this 1/4, what it does is it actually becomes a decay function. So the transformation is a reflection over the y-axis like that.
Okay. Mm.
Questions on that?
Just on on the line on the left that's across. Why is it
Yeah.
like that?
It's this, so this 1/4 flips it over the y-axis. It's the negative exponent. It's basically the difference between 2 to the x and 2 to the minus x.
Mm-hmm.
Okay.
Okay.
So this is a growth and this is a decay function. And it's all based on that x and minus x.
Okay. So it'd kind of be like the opposite of what we're working with, like just like the negative form of it.
Yeah.
Oh, okay, so that's why it's like flipped to the other.
Mhm.
Oh, okay. Thank you.
Right. Give me just a moment here. I'll be right back.
Okay.
All right, I'm back here. So question 7 doesn't seem, I guess it refers to the graph below it. Does that look right to you? Seems like there's something missing.
Oh, yeah, it's to the graph below it.
Problem is it says given 4 functions and I only see one. Did I miss something? I mean, is there a,
I don't think so. I don't know. I took it off exactly what was given to me. So
okay. Well, the y-intercept. Oh, okay. I'm sorry. I'm sorry. I get it. I get it. I'm sorry.
oh,
Trying to figure it better. Okay, so the y-intercept is when x equals 0. Okay,
mhm.
so some of them are very easy to figure out. Like the table, when x is 0, y is 6. Okay,
Yeah.
in the middle one here, when x is 0, y is 4. Now for the one on the right, you have to put 0 in for x. So that's where your calculator is going to come in handy here.
Okay. Do I just type in the 10 parentheses 2 over, not over, but to x?
You put in your calculator 10 times 2 to
Yeah.
the power of 0.
Oh, to the power of 0. Okay. I just got 10.
Yes, it is 10.
Okay. Would we do anything else or would that just be it?
So we have this one more. So Blake is tracking his savings account with an interest rate of 5% and an original deposit of $6. So the starting amount is the answer. The starting amount is $6.
Mhm.
Okay.
What does the 5% have to do with? Do we have to?
Nothing. They're just, the y-intercept is always the starting amount is the idea here. It's the starting amount.
Okay.
Okay. So we got 0, 6, 4, 10. Which is the smallest?
The 0.
I'm sorry, 6, 6, 6, 4, 10, which is the smallest?
4.
It is 4. Good. Excellent. Okay. Right. Right, let's keep going. Number 8 here.
With a graph exponential.
Okay, calculate the average rate of change. So average rate of change, sometimes written as AROC, just for shorthand. What it means is it's really like slope. It's really the y2 minus the y1 over x2 minus x1. But the way that they do it in kind of this part of the course is they use function notation. They go f of 1 minus f of -4 over 1 minus -4, like that.
Question, would you put the
Yeah.
-4 in parentheses so it doesn't doesn't mess with the minus?
Well, the negative cancels, so it becomes 1 minus a -4 is 5, like that.
Oh, okay.
And then f of 1 is the y value. So it's like, what is the y value at 1? It's -4. What's the y value at -4? It's 0. So
Okay.
right here, like right here is an XY pair. It's 1, -4. But the 1 is the X, Y is really f of X. And that's why you're using its function notation. They use this value. Is that clear or is that just totally off, way off?
It's kind of clear.
Okay. All right. Well, let's see what we got here. So this is -4/5.
Okay. And then will we do anything else or would we just leave it like that?
That's it. That's the final answer.
Oh, okay. Okay. The more I'm looking at it, the more I see that it makes sense.
Great.
I just needed to relook at it, see what I wasn't getting at first.
All right, so let's
Is
keep
it-
moving here. Let's go to the next one here. See, the problem with like what we're doing here is it's all disconnected. It's not like one leads to the next to the
Yeah,
next.
yeah.
Yeah. All right, so graph the function f of x equals log base 10 of x minus 2.
I can just plug that in my calculator, right?
Yeah, if you can graph it, that is for sure the best way to go here.
Hmm.
So
Yeah, a lot of it's just like out of place with the study guide, but it's fine. If I can find log. Okay, log. Make clear. I totally forgot on my calculator how to do like the little base with it, so I just gotta
yeah,
find that real quick.
yeah. So you either find that, or I think it's under like math, or you got to use the change of base formula. log x
Oh,
minus 2 over log
I haven't tried math.
10, like that. But here's the thing, that's kind of overkill, because when you just type in log in your calculator, it's implied that it's log base 10. Like that.
Oh, because log equals 10.
Yeah.
Forgot about that. So technically you don't even really need to plug it in, right? Like at
That's
least
right.
the 10 part. So it could just be log x minus 2. And it wouldn't let me graph it. It said it was invalid.
Yeah, so you're using a TI-83, 84?
84.
Okay. So the only thing you have to really to graph this, when you go to Y1, you just have to type in log. You don't need the 10, you just need the log of x minus 2.
Yeah,
You don't need anything else.
that's what I did, but then I pressed graph and it says error.
So make sure you're using the subtraction operator, not the negative,
Yeah.
things like that.
Check values in window. My calculator does this sometimes where it doesn't work sometimes, and then other times it works. Like there's no in between.
If you need me to, I've got a virtual TI-83, 84 I can pull up to help.
Okay, that'd be great.
All right, let me do that here. Is take just a moment to get that pulled
Okay.
up.
I'm sorry. It's just some of my stuff
No,
doesn't work sometimes.
this is part of the lesson, and it's up to you if you want me to show you these things. Let me get that loaded up here. So yeah, go ahead and new share here. So this is the virtual TI-8384. Hopefully you're seeing my screen, and looks like
Oh.
you are. Okay. So one of the things you can always do is you can always go to second mem, which is under the plus there. Second, you hit second, and then the mem go to the plus. And like if you're really like things aren't working, you just go to reset, all RAM, and then click number 2 to reset, and then your memory is cleared.
Oh, okay.
Okay.
Let me try it then. Log x minus 2 graph. Oh, there it goes.
Okay, and then once that happens, you go back to y equals, then you can type in the log x subtraction 2.
And then graph. And,
And then when you graph, you should see something like that. It's not real help. Like this is the worst. I mean, it used to be this was really good technology,
mhm.
but it's not anymore. So hang on just a second. Okay, so that's how you graph those. Did you find the base button on your calculator though?
The base button?
Yeah, like if you had to the subscript. I know in the 84 it has it. For the log base 2 or log base something else.
Oh, yes, 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 yes. I thought you were
Okay,
talking
so you
about
did
like there's like a base button itself. And I was like, oh, I didn't know that.
no, it's like we have these iPhones, Android device now. They're so amazing, and like we go back to use this calculator. It's like, what are we doing?
Yeah, I don't really use the calculator. I tend to just like plug it like into my computer and then it'll show all that.
Yeah, so I use Desmos. If you prefer that we use Desmos, we can always do that. Here
Okay.
is question 10. Put that up in front of you.
Okay.
All right. So what transformation has changed the parent function to its new appearance in the graph? So what you have to know is like, well, what is the parent function? The parent function is going like this. So what do you see here?
Um, it's not really going like past, no, not past, but like above X. It's kind of like going just, I don't know how to explain it. Like it's not going above X, it's just staying below it, if that makes sense.
It looks like it just like kind of dropped down 2.
Yeah, that's what I meant.
So I would just say down 2 units.
Okay. Would it be negative or would it just be 2?
It's just down 2. So when you say down -2, that could be implied as actually going up 2. Because they're like, it's like saying I'm not going to not do something.
Oh, okay. Because the down and the negative kind of like,
When you say down, it's implied that it's negative.
yeah,
Or if you say, and if you say up, it's implied that's positive. So these are like the conventions we've chosen.
I realize that now, like right after saying it.
No,
Oh,
it's an oddity. I mean, our English language is not the not ideal. It really isn't.
not the best.
So okay, so here we go. The next question here is kind of like moving completely away from logarithms and exponentials. It says graph the system of equations. So to graph, you need to first solve for y. So you have to solve each of these equations for y. Do you want to try solving one of these for me? And if you're
Yeah,
totally unsure, you can say so, but
I'm a little confused how I would start per se.
okay.
Um,
So your goal is to get the variable by itself.
both X and Y.
So you're going to subtract 4x from both sides. So 2y equals -4x minus 2. And then you're going to divide everything by 2. So y equals -2x minus 1, like that.
Okay.
All right. And then similarly for the other one here, you're solving for
4. So then instead of minusing the X, would you minus the 3Y? So it'd be like 3Y minus 3Y.
So you subtract x, that's -3y equals -x plus 24, and then you divide by -3.
I didn't know
So
if you should
y,
minus the
yeah.
X because there's nothing really there. Okay, so minus X. Then it would be 3y over X plus 20.
So this ends up being 1/3 x, or x divided by 3 minus 8. So that's y equals, and if you want to graph it, it's x/3 minus 8.
Okay.
And this other one, you put a -2x, but then a subtraction 1 there when you're graphing it. So you just got to put these in y1 and y2, and you should see a nice intersection between them. Let me I'm gonna do it on Desmos just because it'll look a little better for any of the viewing audiences.
Oh, okay. I can see it being like I can see it intersecting.
Yeah. So the intersection actually isn't even that nice, but that is it here. So okay, we're gonna go ahead and stop here for today.
Okay.
I didn't mean to do that. I meant to just stop the recording.
Oh.